Welcome back, engineers. In the previous video, we got some theoretical understanding about how API gateways work, what are their features and core responsibilities, right? In this video, let's have a quick demo about some of those features and see all of them in action. I hope you're ready. Let's get started. So first, we'll start by looking at the design for this demo. So for this demo, we're going to use Postman as our client. We're not going to build any UI and stuff. And then we're going to use NGINX as our gateway tool. Like I said in the previous video, NGINX is one of the popular tools for doing gateway configuration, right? So we're going to use NGINX as our gateway, and this NGINX will be running on some Docker container. And then this is what is our backend. So this is what is shielded from our client side, which is the Postman, right? So in the backend, we have user service, product service, and order service. And I'm replicating the user service in two containers so that we can see that the gateway can also act as a load balancer as well if we have configured it. So within the two services, so let's say this is user service 1, user service 2, which are basically copies of each other. And then we are going to use the gateway to send the request to user's endpoint, and the gateway is responsible for doing some load balancing between these two things. And also when we request endpoints for products or orders or users, it should also act like a reverse proxy machine so that the respective service is called upon depending on the endpoint of the request, right? So these are some of the core responsibilities. API gateway will be used for reverse proxying and also for some load balancing. There are a couple of other features as well that I've configured. We'll have a look at that in the code now. So this is the base design. Now let's go to VS Code. So first let's look at the folder structure. So we have order service, product service, user service 1, user service 2. So these are different services in our backend, and they all have their respective Docker files. And we have a docker compose.yaml for running all these services. And then we have a NGINX config file where we will do all our configuration, right? So let's have a look at this docker compose file. So we have user service 1, user service 2, product service, order service, and API gateway. And each of them are having their own respective Docker files. So if we just click this, we can start all the services. Let's give it a minute. Okay, all the services are up and running now. We can verify this inside Docker containers. So we have the different services. We have user service 1, user service 2, product service 1, order service 1, and also API gateway, right? So NGINX is running here and it is exposed in port 80. This is what we're going to use to call upon all of our APIs. And then internally, it's going to take care of rerouting the request between all these different containers, right? So first let's have a demo and then I'll show you the different features. So let's go to Postman and we'll just hit our users API. And we get back the response 200 OK. We have some dummy data response, right? So similarly, we can go to the products API and we hit it. We get product response, and we go to orders API and then we get some order data, right? So if you look at the URL, it is localhost 8080 for users, 8080 for products, and 8080 for orders. So we are hitting the gateway on port 8080. It is redirecting the request to the respective services and getting us the respective response, right? Now let's look at some other features. I have also added configuration to include authentication into the API gateway itself. So I've configured a header, something like API key, whose secret is 123. So let's say I give some other secret, it's going to throw me an error 403 forbidden, right? So this is not coming from the user service, this is coming from the API gateway itself. So I have configured the gateway in such a way that there is also authentication taken care, right? And I've also spoken about load balancing, right? So this /users request could be going to user service 1 or user service 2. So in order to see how it's redirecting, I've added a response header which will give us the service name from which the request is coming from. So this request was serviced by user service 2. If I keep hitting it, now it is serviced by user service 1. And again, I hit it, it is coming from user service 2. So I've just added this flag so that we can see the load balancing happening. So it is kind of using a round robin mechanism. So one request is going to service 1, another is service 2, and so on, right? So we've seen authentication, we've also seen load balancing. Now I would like to show you the concept of rate limiting as well. So the way I've configured it is, for the users API, we're going to have one request per second, right, from an IP address. And I've allowed a burst of 5 requests. So up to 5 requests within 1 second is allowed, plus one additional request. So beyond that, if we hit any number of requests, they're going to fail. So for this, I've given a simple loop in the README file for you to check out. So you can use this loop to call any number of requests. So this loop is running 10 times, and we're just hitting the same user's endpoint with the header API key and so on. Let's see what happens. So when we hit the same endpoint 10 times, this is what has happened. Let's take this output so we can analyze this. So if we look at it, there are some requests which went through and we received some response. So if you look at it, there will be 6 such requests which went through fine, right? And we got 6 different responses. And then we have 4 requests that failed. If you look at the head tag, 4 times we received temporarily available 503 error, right? This means that out of the 10 requests, 6 were successful and 4 failed. This is because of the configuration I've made, which shows that allow up to 5 burst requests. Burst requests are quick bursts of network requests and within 1 second, right? So that's the configuration I made. So this same API gateway is acting also as the rate limiter as well. So we can also check this in the logs. If we go inside the gateway and see the logs. So here we can see that there are 6 requests which went through fine, which were coming from the curl. These are our earlier Postman requests, and these are coming from the curl that we are hitting, and the remaining requests are later rate limited, right? So the API gateway is also acting like a rate limiter. So that is also one of the features. Let's see if I have missed any other feature. So I've shown you how reverse proxy works, I've shown you load balancing, I've shown you authentication, I've also shown you rate limiting, and we've also seen header injection, and of course logging. So I've also enabled logging. So the things that we are seeing here, so the logs that we are seeing here, IP address followed by timestamp, followed by request method, followed by the endpoint, followed by the protocol, and so on. This is a format that is custom configured in the NGINX file itself, right? So this is also another feature. Now let's have a look at the configuration file which is doing all this. So the configuration itself is quite simple actually. So we are saying that use one worker process, like use one thread, and then you can handle up to 1024 connections within that thread. And then this is the log format that I spoke about. Give me the IP address followed by the username, followed by the timestamp, and so on. So this is the format of the log. And then we are saying where the location to put this log. So this is the access log, and then this is where the rate limiting is happening. So we are giving it a name called API limit, and then we are saying use up to 10 megabytes of memory for handling this rate limiting logic, and the rate is 1 request per second, right? And the next one is to set up a user cluster. So this is where the load balancing is happening. So we have user service 1 running at port 3000 in user service 1 container, and then we have user service 2 container which is also running on port 3000. So both of them will act like a single cluster, and the load balancing is taken care here. And then we are configuring the server details. We are saying that you need to listen on port 80 inside the container, and that port is exposed to our outside world. And then here we are configuring the actual endpoints. So when we are hitting /users, we are saying that, so if there is no header called API key with this particular secret, you return 403, which means that authentication is taken care here itself. And then this is where we are configuring the rate limit. So we are giving the name API limit, which is the name we have given here. So it is handling about 1 request per second, but I'm also allowing a burst of 5, which means you can do up to 5 quick requests. After that, I'm going to block you, right? So that is what we're doing here. And then which cluster to use. So this is the name we are giving here. So you can use user cluster, which is this one, which is internally holding 2 other server nodes, right? And then similarly, we just do redirection for products. So use product service 3000, and for orders, use order service 3000, right? simple configuration. So the configuration itself is quite simple, and this gives us a lot of control and power as to how NGINX works, and we can give a lot more responsibilities to our API gateway, right? So if you want to try this out, I have given all the instructions in the README file, so definitely check it out. The code is already available on GitHub. I'm going to leave a link in the description below, so definitely check it out. Play around with this file, change your configuration, maybe remove the burst, maybe increase the burst number, change the API limit, and test it for yourself, right? So that's all I had for this video, guys. Thank you so much for watching. If you have any doubts, definitely let me know in the comment below. If you found this demo helpful, definitely leave a like, and please subscribe to the channel if you haven't done already, so that you don't miss out on future videos. Thank you so much for watching. I will see you in the next one. Cheers.